Hello, welcome to another Random Code stream. I gotta do one more thing here before I start that I forgot to do. There we go. All right. So, gonna get started. This is weird. I think I took off my wedding ring when I worked out yesterday because I was doing weights. And so when I do that at home, I take it off just because I don't want to get scratched up. I think I left it near where I have all my free weights, my dumbbells. And I keep forgetting to go look for it again, but it is this weird feeling. I've been wearing this ring now for nearly 30 years. And so when it's off for a significant amount of time, I'm always like, what's weird? Something doesn't feel right. So anyway, let's get some music going here. All right. So what I'm going to do in this stream is this feature I'd like to add to Spackle, which is a library that I've had for many years that has just little utility methods. Everybody always has that, but they call it like utilities, and I didn't like that name, so I've called it Spackle. And it's had things that have come and gone over the years, but you know, they're things that I think in some way should be useful and also self-educational. Like I learned something by doing it in some way, shape, or form. So this one is an idea that I had because I've used big integers in the past, and I thought, instead of like when you get a number that's really, really big, instead of printing out the whole thing, could I print out just a part of it? Like, could I have, if you see here, where I just print out the first 5 and the last 5, or I could say the first 3 or the last 4, or just the last 4, or just the first 10, or something like that, you know? And how would you do that in a, because you could print out the number, get the ToString, figure out the length, and then chop it at the beginning and the end. That wouldn't be a big deal. But I thought, is there a more efficient way to do it? And somebody had the idea of using like a temp buffer and then formatting it and then, you know, kind of chopping it the way I was mentioning using string create. So that you only create a string that's this length, but you still have to end up formatting the number. And by formatting it, meaning getting it in a string version. So I want to try to avoid that. And so what I came up with is this. And I actually just did my own console app 3 because, you know, you got to do that once in a while. I could have used the file-based thing. It's weird. I like the file-based idea, but if you're going to be in Visual Studio, then you might as well just make a project, you know. So, yeah. So what I did is I put in a number here. Let's make this a little bigger for broadcast purposes. And then I wanted to see what it would look like if I did this with base 10 and base 16 and support those out of the box. So I came up with this idea. You get the absolute value of it. So again, there's some allocations that are going to be going on here to make other big integers, which I'm not entirely happy about, but you know, I want to put this in first, and then we'll look at doing something where is it actually cheaper to print it to get the whole number and then chop off the parts, you know, something like that. So I'll do some perf tests afterwards, but I want to get this in first to see if this is the right way to do it. So we get the absolute value of it. And then this is a way that you can get in a base how many digits are in the number. So there's some links up in here if you want to look at the math around it, that you can do that. So we figured out the digits. Then to get like the number X number of digits in front of the number that are at the leading part of the number, you basically divide it by raising a number by the number of the base by how many digits are there minus that many digits that you want. And then you divide that out and print it. And then on the right side, you could just do a div rem, where you basically divide off the right part that you want, and then you get that as the remainder, again, using the base. Now you may wonder, why is there this trim leading 0 here? This is here because I found out last night as I was playing with this that when you do a big integer ToString and you say I want it in hex format, sometimes depending upon the number, you'll get a leading 0 in front of it, which is really bizarre to me. It makes sense in that now I've figured out and I've been told why that happens, but it also seems like an abstraction problem. The way that a big integer is stored is essentially they use an array, and there's this thing about how they do two's stored and two's complement, and that the leading bit or something like that stores the sign. And so if they want to be able to round trip a number, like I take a big integer, I say ToString in hex format, and then I want to take that string format and put it in and parse it as a big integer, they need that leading 0 so that it formats to either a positive or negative correctly. And I'm just sitting there going, that seems bizarre. Why are you forcing that onto the user to understand that? Why don't you handle it? Like, I don't think there's any integer, whether it's a 16-bit integer, any of the I know there's bytes and shorts, but those are integral types. Those are there's like 8-bit, 16-bit, 32-bit. That's an int, uint, 32 long, ulong. No, I'm sorry. That 32-bit is the int and uint. 64 is long, ulong. There's an int 128, and I think there's maybe an int. Is there an int 256 now? I don't remember. There's an int. Yeah, there's an int 128 that doesn't have like an alias or a keyword in C#, but you can do a 128-bit number. I don't think there's a 256, no. But I believe all those will not do that. And so I don't understand. Human-wise, it feels weird to force a user to understand, oh, there's a 0 in front of the number. If I want to print out 256, I don't put 00256 in front of it. It's just, I don't know. I felt like that was a little bit of a... Calculator handles it correctly. Calculator in Windows will show the number without a leading 0. So anyway, and I think I'm going to have to do that on these numbers here too. That, what is this? Use range operator. Okay, fine. So we're going to have to probably do that on these two. In fact, I should, just for remembrance purposes, is that when I do this, and then we say here .ToString, passing that in. Okay, and then, so anytime we want to get a stringified version of any of these numbers, we're going to have to do this, where we're going to have to trim off the leading 0, if it exists. If it doesn't, then we don't do anything. So anyway, but this makes it simple in the sense, all of this here is we pass in how many digits we want on the left and how many digits we want on the right. And so you have to have the left digit, like left number digit, right number digit. One of those has to be greater than 0. And both of them have to be not negative. And one of them has to be greater than 0. You want to think about it that way. So we can create an extension method on BigInteger on a ToString, because on BigInteger there's just these overloads. So we could overload it with those two values in there, and then also provide it where you can pass in a format which will support X. And we can say, we support, this is primarily to say, hey, I want to format it with hexadecimal. Okay, so that's what I'm going to be working on this stream. It might take this stream and the next one, because again, I just want to play with performance numbers and see if just chopping it off like here and then here at the end here, is that going to be actually better than what I'm doing here? And frankly, I don't really know. That's why doing performance checks is always a good thing. But we're going to go with this approach first. All right, so I have a branch here all ready to go. And we do not have an extensions, BigInteger extensions. Okay. What version are we on? 18.1. Yeah, some of the problems I've run into with XML formatting, XML comments and formatting and stuff with extensions, I'm not really too keen on moving towards the extension keyword just yet. It's important to me to have that worked out first, especially as a author of a library or a package. So we're not going to do that just yet. We're going to need numerics. These can go away. Okay. So let's... Oh, that's... provides extension members for cref hash set of t. BigInteger. Okay, so let's say we want to have a public static string, ToString. This BigInteger value, self. I always do self. The format, we're going to know. We want to have an integer that says, naming is hard, left digit count, and then int right digit count. Okay. Gets a formats a what do they do if I say self dot ToString? Converts the numeric value of the current, converts the numeric value of self. To LLLL dot dot dot. Where the left beginning most significant, I don't know, the left most and right most digit are controlled by and a formatted version. Does it say here what it returns? Of self. Remarks. Here are a couple of examples of what this extension method will do. So how do I want to show this? Value self equals 1, 2, 3, 4. Let's just put in a big number. Self dot ToString. We don't want to do the format just yet. Self.ToString of 4, 4 would produce 1, 2, 3, 4 dot 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 3801. If we say 04, it's going to be that. If we say 40, it's going to be this. And then we want here string format. So this is just simply going to turn around and call now. This is also where I got to look up and say .NET BigInteger custom format ToString. So this standard numeric for strings would be, we want X because that's hex. What is D? No, I don't want that. Custom numeric format strings. Okay. Why? Just standard numeric format strings. D, decimal, that's not what we want. N. So we'll support either N or X. N or N or X or X. Okay. Note that no. Ah. The only supported. Well, we're going to put that in. So here we're going to say N. And then we're going to put X here. And quite frankly, I don't know what that's going to be. So I guess we can use my program here real quick. and say, let's get the first. Yeah, let's keep it this way. And we'll do that as a test. We don't know. What are the characters going to be? We don't know. Actually, no, I do know. Let's take this and go to calculator, because we know that works. No, not that. Oh, yeah. That is the number I put. Okay. OFE9. That's even doubly interesting. Because in this case, you actually do want to show that it is... You do want to show that the last 4 digits actually are 0. Because that is correct. You can't truncate that off. So we also got to be a little cautious here in terms of what's produced when we get those last 4 digits. And not just truncate them off. So this is this is fun. So it's 1122. But then be OFE9. Okay. Exception. Argument exception. Thrown if both paramref and are 0. So if they're both 0, it'll throw. So that means, or if either one is negative. I think that's correct. The number to format, the number of digits to show on the left hand side. The format to use for the result. So in this case, thrown if parameter x n x or x. Okay. Okay. So what we want to do is we want to take the number that we have, and the first thing we want to do is, well, we want to say first, let's do our checks. If left digit count if it's strictly less than 0, then throw new. Does argument exception have, no. No, that's not the ones we want. Should this be an argument out of range exception? The exception is thrown a value of arguments allows you. Oh yeah, that actually makes more sense, actually. I think we also want to do a check to say something like value cannot be negative. Okay. And then we want to say this. And then we also want to say if left is equal to 0 and right. Now this is interesting because this is digit counts at least one digit count must be greater than 0. And then like this, yeah. We want this on both parameters because it's wrong on both of them. And if we say argument exception, then that's not right. Because again, you need it on an argument. Oh, let's do not supported. There. Okay, so thrown if both okay, so thrown if either is negative. Then not supported, thrown if both are 0. Okay, okay. I feel like I spent the entire stream so far just doing nothing but documentation, but in an odd sort of way, this is needed because this kind of sets the expectations, again, as a library author, of what you want people to see when they're using your library and what is expected to show up. And happen when they make the calls to your stuff. Okay. So Oh, and then we got to check and say if format does not equal X and format does not not equal, I can't type, and format does not equal N. I don't know if it's an and or an or. I hate the suggestion that I'm getting here. It's not what I want. So if it doesn't equal, yeah, it should be or. If it doesn't equal that, or it doesn't equal, well, no. If it doesn't equal this, or this, or this, or this, there we go. Throw a new argument exception. Name of format. The format value is invalid. Why are you complaining? Oh, it's the other way around. Because of course it is. Jeez. Okay. All right, now we can actually finally do some math. In this case, we're just passing in n. We should pass in the correct value to what we're doing here. All right, so now what we want to do is we go back here, and the first thing we want to get is an absolute value of this number. And this is important because it affects some of the math that happens later on that we want to make sure is correct. Positive self. Why are you suddenly complaining here? Format is always true. Remove or refactor the conditions to huh? Wait a minute. If it equals X, or it equals X, or it equals N, or it equals N, that's what we want. It's got to be one of those. If it doesn't equal one of those, then we have a wrong number. Okay, I think that's correct. Yeesh. Okay, so now we have the positive self. And now we want to get digits. We're just going to assume that we're doing this in the right base. Okay. So we're going to want to say var base, which is a keyword. So we got to do base here. Is if format is equal to X or format is equal to X, it's 16, otherwise it's 10. Okay, so now we get the digits. We don't care about the base. I mean, we do. Okay. I think the way we're going to be able to tell if we do a trim is we want to say how many digits do we actually desire. If the result that we get is one more than that, then that means it got that extra 0 in front, and then we can trim it off. I'll have to check that to make sure, but I think that's what we're going to want to do here. Okay, so now we want to get static trim leading 0. Hey, Orange Cat. Static string. So we want to say string value. That's fine there. I am doing well-ish. How about yourself? I say that because it's fun times in the Twin Cities. So we want to say string, and then we want to have an int desired digit count. So if value.length is greater than the desired digit count, then in all likelihood we got a leading 0, right? So if I come back to this case, I think this is where I ran into this. If I put a breakpoint here and I run this, if I run this using F5, and now my keyboard switched over. Okay, now I step in. Oh, I didn't step in. Hit the wrong key. There we go. So now you see it's 0 CCB. That has too many digits on it. What we want is 3. So we can chop off immediately if the length is greater. Okay. We're not going to do any math if we don't have any digits to show. So I think that simplifies things. So we're going to say here, if the value length is greater than that, then we simply chop off. Okay, so now we come down here and we want to say var left format is equal to, if the left digit count is greater than 0, we're going to do something, else we're going to do something. Okay. So here's where we're really going to do something if the digit count is greater than 0. So what we're going to do is, I think what we can do is to generalize this. Is something like this. Positive self. Then we're going to want to take the base, the digits, -5, and then we want a ToString given the format that we have. And then we also want to pass in now how many digits did we desire, left digit count. Otherwise we do that. And then here we do right format, and we say if the right digit count is greater than 0, then we're going to do different math. We're going to do this math. Right? So we're going to say positive self, put in the base, and then how many digits we want on the right digit count. Remainder ToString with the format, right digit count. So that does that. Wait, what got... Cannot use local variable before it is declared. How or why? That doesn't make any sense. Oh, maybe that's what's screwing it all up. Okay. Wow, one little parenthesis off and everything just falls apart. Okay. So we're going to want to say BigIn POW at the base and how many digits we want on the right. Remainder ToString with the format, and then make sure we trim and then do that. And then now we want to say here, return, we're going to do a formatted string. So we're going to put here, self is I thought I had something in here to be negative. It's easy to check. If self is less than BigInteger 0, then we're going to put in a minus in front. Otherwise, we put an empty character in. And I think if for a ternary, it needs to do this. Empty character. Oh, well, yeah, okay, fine. Fine. Okay. So we put that in at the front. And then we're going to do left format, ... right format. And we're done. Please subscribe to the channel if you haven't already. Okay, so I think this is what we need. Obviously, we need a ton of tests. A boatload, as it were. And we typically do this as the check in the ternary because you're probably going to want to put numbers there, though you may want to just look at the ones on the right or the ones on the left. So we'll do that. All right, so now let's get some tests in here. BigInteger extensions tests. Okay, stop with the fact. Jeez, I'm using NUnit here. Public static void format. And I think here we could probably do a test case scenario. So let's say I wanted to have a number like here, okay? And we put that in there. And I want to format it with BigN. And I want 4 digits in front and 4 digits on the side. And what I expect it to be is 5907 ... 1531. Okay, so now we want to say format. We want to say string value, string format, int, what are we calling this? Left digit count, int, right digit count, string expected value. Okay, so what we can do is we can say assert that value.ToString passing in using spackle extensions oh, come on, you're not going to pick that up. We want the format left digit count, right digit count is equal to expected value. And we can do that as an expression body member. And you're like, what is ToString? I don't know. You should know what that is. Oh, duh. I need to big integer. No. Parse the value. Now, at least that works. Okay. We got that into place. Does this pass? No, it doesn't. Okay, well. Shoot. Well, that is some... That's not what I expected. Because I think it's the end of the formatting. We want it to be a binary. No, we don't want binary. Although we could support binary eventually. I mean, that's the thing. We could do octal as well. If we really wanted to. What is the decimal for? I thought decimal meant like literally decimal. Of decimal. Maybe that's what we meant as D. Okay. This is why we do what, folks? We write tests. Nope. Okay, now what does the test do? Still fails. The format value. Line 11. Okay, so we're not... Oh, did I not change it? Oh, shoot. Still fails. Okay, it's getting the right part. The left part, though, it's off. Interesting. Oh, because I'm hard coding the stupid value here. There we go. First passing test. A lot more to go. A lot more to go. But at least we have a test case. So now let's do the same thing with D. And now we should have 2 passing values. Right? Okay, so now we're going to just keep ramping this up. We want to have here 0, 0, which means that this should be 0, 0. And that works. And we want this to be 4 and 0, 0. So that should be that. And that works. Okay. So we're handling all the D cases. We have this, this. Now let's make them all negative. And now all of these should start with a negative. And that all works. It looks weird. I mean, when you don't have any digits in front, it's a minus blot and then that. But it is correct. Okay, well, what should a hex do? I have no idea. And unfortunately, this is where calc falls apart because it can't take a number that big. So I think even if we did it, yeah, it's just too big. Let's just see how good Bing is. What is in hex? Yeah, I know that. You idiot. I know. Okay, fine. Hex calculator. Convert this to hex. No. You need the whole thing there. Come on. Oh, you suck. Jeez. Alpha. Wolf Ram. Or whatever that is. What is the hex format of? More digits. Oh, I want more digits here. Okay, so we expect to be 43D0. 43D0. And then 4CCB. Now here's another thing. I'm going to comment all these out first. And the reason why is because I think this is where the hex, the capitalization of it matters. And that's something else I'm going to have to put here too, which is that should be a lowercase d, I believe, when we're doing that. But we'll see. First of all, is this correct? It is. Okay. What about this? 43D0 4CCB. Are these correct? And they are, so I did do it right. Nice. Let's uncomment all these now. And let's get all the rest of these correct. So that should be that. And then this should be 4CCB. This should be 43D0. And then 43D0. D. And then let's just do that. That. And then let's grab this and get it in here. Nice. Very, very nice. So we're getting a compact version of the BigInteger extension tests, which is what we want. Now, as we saw, when I put this in here, we also want to have tests where we're going to get an expected leading 0 and a not unexpected but undesirable leading 0. Okay. So we should put those in there as well. And I think in this case, let's make this a little bit more explicit of a test. Static void. No, static method. What is that? Oh, that's from something in unit. We don't care about that. Static void format with expected leading 0. Okay. So we want to have a number like this. We want to assert that BigInteger parse ToString. We do X. And again, I'm not going to do upper lower. The previous tests, I think, handle that, so we don't need to really care about that. And we want to say 4 and 4 is equal to, and then we're going to put in some value here. So in this case, what we expect it to be is this. Hex format and oh, boom, pow, smash. Oh, it's a not an O, a 0. Okay. Did I do that wrong here? Yeah, I did. Jesus. Okay. And then we want to... Oh, we don't, because if you do it this way, we should also... Yeah, we also want to test that and just say... test with format and then test without the form. Okay. With format specified. With normal format. So in this case, we're taking this off. So that means there's going to be no X ones in here. And so in all these cases, we just need to remove the format because we're expecting it to be a decimal format. There. So now this should work. Okay. Those we know that works. That works. Now the unexpected one. And undesirable. Undesirable. I think that's how you say it. And I think I have that in the one I was working on last night, which is we want this. And then we want to say, it doesn't matter. We can say 3 and 3. And I know this isn't right. But actually, let's go to alpha again. And oh, yeah, right. Okay, we already did it. So we want 4-3D. 4-3D, and then we want CCB. And that works. Boom. I think we're actually good. I think we're done. Oh, we need tests with all of the exceptional cases. Hold on one sec here, real quick. All right. So we do need exceptional cases tests. For example, something like public static void format with unsupported format value. So in this case, we want to say that assert that. If we say BigInteger dot parse, it doesn't matter. It can be 1, 2, 3. And we can actually do new BigInteger at that point. Doesn't matter. We could actually say 0 for all we care. ToString, and we put in Q as the format. 3, 3. Throws type of not supported exception. What did it do? Argument exception. Should it be format exception? Exception is thrown when the format of argument is valid or composite format string is not well formed. No. Argument exception. Yeah. With param. Yeah, we could check all these. I'm not really caring. I just want to make sure that we're handling that specifically. I guess we could say with the message and all that stuff, but nah. So we won't get that if we call this one, because so now we want something like format when left and right digit counts are negative. So in this case, we're going to say -3 and -3. And we should get an argument out of range. Right? And we do. Format with format. So now we're going to put in a valid format string, but we're still going to do that. Because you could call one or the other, and we don't want to rely upon the chain that we have in our code. This is testing it as though we don't know that. Okay. We should test them separately because we are testing. Yeah, okay. When left digit count is negative. Because we could say 3 here, and then we'll say left digit count is negative. Run all the tests. They're all so fast because that's fine. And then we'll say here, we'll do right digit count. So this becomes 3 minus, and this will be 3, and this will be a minus. And we could make sure that we're catching one of the, but just the fact that we're passing them in is fine. Okay, and so we got those. And then we need the not supported. So we want to say format when left and right digit counts are 0. That is illegal. And what is this? Not supported. So now I say format when left and right digit counts are 0. Oh, one failed. Oh, because we didn't change the exception correctly. Boom. All tests are in. Nice. Let's go to the changelog real quick. I'm going to say added a ToString extension method for BigInteger for minimal formatting scenarios. And this is 33, right? That's what we've been putting in. Yeah, this is a feature I've had around for an idea for a while. And I finally said, let's just do it. Let's just do it. And then I should probably do a release, package that up, do a release, get that out there, and get a 14.0 with some of these things in there. Yeah, I kind of like the malleability of this library and changing stuff. Like, we've now completely removed secure random, and we've made it all extension methods on random number generator. Because it really, that's all we're doing is extending any kind of random number generator. As long as you derive from it, all these will exist on it. We don't need you to create a custom one. Because random number itself, there is a random number create, right? And that just gets you the default one. So, and then you could use one of these extension methods. And you're done. I just had a thought. Could we put these extension methods on the static type itself? And that would use the default one? Ooh, could we do something like extension random number generator, but that's it. And then we say here, public, like big integer, get big integer, long number of digits, let him cook. Random number generator, create. get big integer number. Cannot declare instance member. Oh, this would be static. And then, damn it, can we just ignore that? Well, look at that. We could do that. Okay, I'm just going to cut this out because we don't want to put that in here. But I'm going to merge all this. I'm going to put it up there. But then I'm going to put this feature in because that would be cool, because then you don't even have to create an instance of it yourself. You could use these extensions as static extensions on that type, and it will do it on the default one for you. Ooh, I like that. So I'm going to stop for now because I got stuff to do, but I will probably work on that tomorrow morning as another random code stream. So thanks everybody for stopping by. If you haven't subscribed, please do so. I would really appreciate it. I will be doing some control streams, at least one this afternoon and then tomorrow. And then Monday I have off for Martin Luther King Jr. Day. So I may be doing some streaming on that day as well. But for now, I am done. Thank you all for watching. Take care, and I hope to see you in the future.